In this video, we are going to see exponential signals. So let us start with the first type of exponential signal, which is CT signal. The signal is represented as x of t equal to a into e raised to minus alpha t. So here if you look at this equation, here this capital A represents the amplitude of this exponential at origin. This minus alpha represents the slope of signal. So if we plot this exponential signal, it is in this way. We have axis time, origin and x of t, and now this signal will be represented as, see, we have a as the scaling factor for this exponential. So at origin this signal will have amplitude a, and here the power of exponential is negative, therefore this signal is called as decaying exponential, and we get this kind of signal where at origin this will be a, and the slope of this signal is written as e raised to minus alpha t, and this signal is called as decaying exponential. Similarly, if the slope of signal is positive, that is if x of t is a into e raised to alpha t. Now here this alpha doesn't have negative sign, so in this case this signal is called as rising exponential, and it is drawn in this way. At origin it will have amplitude a, and slope of this line is e raised to plus alpha t, and this is rising exponential. Similarly, in discrete domain, we will represent these signals as x of, now it is x of n equal to a into e raised to minus alpha n, and signal will be drawn as, so mark the points. So now this signal is e raised to minus alpha, so it is decaying exponential. So towards negative axis we will have maximum amplitude, and this amplitude will go on decreasing towards positive side. So at origin we have amplitude a, and this will be your exponential signal. Always remember, whenever it is discrete signal, we are drawing the samples at only integer values. Similarly, if we have slope positive, that is x of n equal to a into e raised to plus alpha n, this signal is drawn as, again, axis. Now this, it is, just make a correction. Now in this case slope is positive, so it is rising exponential, so we have maximum amplitude in the positive side, and this amplitude will go on decreasing towards negative axis. So this will be your exponential, and remember this is approaching towards positive as well as negative, and same is the case for the first signal also. So these are the representation for exponential signal. So this is the entire CT and DT representation for exponential signal. Now we'll see one example where you will find it in many of the examples. This equation is given as x of t equal to e raised to minus at into u of t. Now here we have two different signals. One is exponential and another is unit step, and we are multiplying these signals together. So if we draw the signals, as we know, e raised to minus at is a decaying exponential. So we'll have this signal in this way. And second, we have unit step signal, which is one only in the positive axis. Now if we multiply these signals, so if we look at the negative axis, here we have exponential, but for unit step it is 0. So exponential multiplied by 0, we get 0 signal. Second, in the positive axis, this is our exponential. Exponential multiplied by 1 is the exponential signal. So here we get exponential signal only on the positive axis. So whenever you have an equation like e raised to minus at into u of t, you will get an exponential signal starting at 0 and approaching towards positive infinity. And here if you look at the coefficient of e doesn't have any value, therefore by default it is 1. So if we have any value over here, let's say it is 2, in this case this amplitude will change to 2. So this is how we can draw exponential signal multiplied by unit step signal.